on the importance of concrete surface preparation and the key to preventing avoidable failures. It's a good topic. We need to be reminded of this, and it is not going away. So hopefully out of Mike's presentation, there'll be a bit more clarity on what is getting done badly and how to avoid it. Mike's the Principal of Conspectus Queensland Proprietary Limited. They're an independent consulting company providing specialist asset maintenance engineering and asset management support services. Mike's got more than 35 years experience in concrete remediation protection, going throughout product development and marketing, contracting and consultancy positions. He currently holds a position with ACRA Queensland Sub-Branch Committee and is in the ACA Applicator Technical Group. He's an active ACRA board member as well. He's got industry, corporate and individual memberships with ACRA, the ACA, the CIA, NACE and the SSPC. I'll hand over to you, Mike.
Thanks very much, Graham. Okay. The repair and protection of concrete structures is probably amongst the biggest challenges we face today and will be in the years to come. The current focus is on sustainable development, which emphasises repair instead of new construction. It's bolstering the trend. In the same regard, repairs to concrete structures need to be as long-lasting as they possibly can be. Engineers, researchers, manufacturers, and contractors are devoting considerable effort towards improving the durability of concrete repair and concrete protection. One of the critical aspects of durability of all repair and protection is a lasting bond between the materials and the existing concrete substrate. The critical component in achieving adequate bond is the surface preparation and the condition prior to the application of the repair or concrete protection system. Before we get too far into it, I just want to say a disclaimer as such. All I'm saying here is that our webinar registrants are from a wide range of backgrounds involved in our industry. We've got manufacturers, we've got equipment manufacturers and suppliers, we've got those who specify, we've got surface preparation contractors, we've got concrete repair and protection contractors, and specifying consultants. This webinar is basically designed to create the awareness of the importance of surface preparation and what we can do to prevent failures. There's probably going to be aspects within the presentation that technically manufacturers or equipment suppliers, contractors might say, well, hang on, that's not quite right. We'll realise that, but I will say that we'll be going up on our web, so more in depth to it on there. The webinar outline is basically we're going to look at the facts and goals and choices of surface preparation, the assessment and evaluation of methods, the failure mode, avoidance, remediation, protection, material requirements. We look at if a product's specified, what the requirements are of that material in relation to surface preparation. Site requirements, every site's different, no two jobs are the same. Considerations that we need to be addressed in selecting the correct method and how we go about it. We'll also briefly touch on the International Concrete Repair Institute concrete surface preparation chips, which are becoming more commonly specified and used on projects. And we'll look at the mechanics of different types of surface preparation techniques that are out there. Also industry standards that relate to surface prep. And the big one at the end, the failure avoidance strategy. With respect to successful concrete repair and protection project, the surface preparation is probably the most important part of the project. You can have the best system in the world, you can have the best contractor applying it, but if the surface preparation is inadequate, they'll remember the name on the drum and the name on the contractor's door. Proper surface preparation is a key to all successful concrete remediation protection works. And inadequate preparation necessitates further work, adds further expense, compromises the integrity of the concrete remediation and protection works. ICORI, NACE, SSPC are all promoting the same fact, and that is 95% of all coating failures are due to inadequate surface preparation. Now, that can be not just inadequate surface preparation, it can also be application procedures. They might want to mix product with a stick because they didn't have a mixer, but 95% of failures come out of surface preparation and application. There's a case history over there on the screen. You know, you can see there 3 weeks after application. This is on a water treatment plant filter. 3 weeks after application, the high build coating was washed off the concrete surface. And findings out of that was there was an inadequate surface profile on the concrete to provide an adequate anchor pattern. It was prepared by low pressure water jetting. And I guess too, the anchor pattern that we're looking at here is not so much pull-off intention, but we had water running over it. So the loading on that coating was a shear loading going across. The anchor profile was obviously inadequate to do that. We had inadequate product cure before recommissioning. That didn't help. Shutdown was required to remove defective coating and re-prepare and recoat to let it cure prior to recommissioning. It was 3 weeks all up, so it was costly to the client and costly to the contractor. Surface preparation. This is the goal. Surface preparation is the process by which sound, clean, suitably profiled surface is produced on a concrete substrate. Preparation includes the removal of latents, dirt, oils, films, coatings, sound, unsound concrete, and any other material that will affect the receptive bond of a system to the concrete. Surface preparation opens up the pores of the structure of the concrete and establishes different profiles suitable for the application of the protective coating system or the repair materials that are specified. The choice. Upon consideration of relevant issues, a particular method of concrete surface preparation is usually more appropriate for any given project. And as I said before, most projects are they're different. There are many factors to consider: cost, containment if needed, clean up, surface profile required, health and safety issues, which is a big one. These don't represent all the issues, but they're certainly the bigger ones. Assessment and evaluation. Still on the choice. In some instances, a single factor may be important that all other factors combined hold no influence over the choice of preparation method. For instance, if the situation is one where moisture can't be tolerated at any level, well, we then look for abrasive blasting and employ that regardless of cost, containment, dust, or any other issues that we'll be considering. It's a life of concrete repair and protection hinges largely on the preparation, proper preparation. It's often been said that over 60% of good concrete repair and protection applications through proper surface preparation. It's probably a little bit higher than that. Well, it's at least 2/3 of the job. The assessment and evaluation, we've got to look at the substrate condition. The substrate, including presence of unsound concrete, bonding human materials, deterioration, cracking, surface contamination. It all needs to be put into the package to evaluate and determine the nature and the degree of the surface preparation required. The preparation must provide a clean, sound substrate, surface profile appropriate for the specific material installation. The surface conditions are important. Effervescence, surface imperfection, latent bug holes, dusting, exposed aggregate, abrasion or cavitation, damage, previous repairs that may not be sound, any contamination that will possibly not be receptive to the bond of material going over the top, curing compounds, existing coatings, and oil. Soundness, the soundness of the concrete, delaminated concrete, spalling concrete, surface strength, the porosity of the concrete, alkali reactivity, sulfate, chloride content and penetration depth, carbonation depth, and pH of the concrete are all important considerations. We also have to look at the likes of hazardous materials. In a lot of instances, we're getting repair and remediation and protection jobs where we have joint sealing in there that is pretty old. It can be hazardous, contain asbestos or tar. We also have areas in industry where concrete's been exposed to chemicals and has basically impregnated the surface of the concrete. We'll look at the finish of the concrete too, whether it's formed, whether it's wood float, steel trowel, power trowel, broom finished or Hessian sack finish, as to what we're looking at in relation to the concrete surface. Also moisture. Moisture can be through the maturity of the concrete, it's fresh concrete. We've also got to look at hydrostatic pressures, substrate moisture content, the internal relative humidity that we test by putting a probe into the slab or into the structure. Moisture vapour emission, is there a vapour barrier present or there's no vapour barrier? Is the area subject to drainage? All considerations. We've got joints and cracking. We've got cold joints, construction joints and expansion joints. Then we have the likes of dynamic cracking, static cracking and glazing. And we also have cracks, water ingress and things like that all need to be taken into the equation. The general observations, such as permeability, that may inhibit the likes of penetration, section thickness and required depth of removal. On that slide there, that's basically a bit of concrete that's been removed out of a transformer bund. You can see there that the oil has penetrated to probably about 14 millimetres in depth. So really, to get back to sound, firmly held parent concrete that's going to give it a receptive finish, basically 14 mil got to be taken off the surface of that to get something that we can actually bond to. Can't bond to the oil contamination, it's oil in itself as a release agent. We've got the likes of failure mode avoidance. We have a lot of problems with holes, bug holes and pinholes and things like that. Bug holes there, the small crater-shaped holes caused by the concrete breathing. That's the result of the slab increasing in temperature. Usually it's magnified during exterior applications when exposed to direct sunlight. However, interior surfaces can experience the same phenomena, but usually to a lesser degree. This can be avoided by applying coatings and repair materials, or at least a primer or a seal coat, as the concrete has reached its maximum temperature. In other words, late afternoon when the substrate temperature is falling, it's the best time to do it. Once you get your first coat on, your prime coat on, check for blowholes and correct those before you put any further coating on it. Bug holes, the surface imperfections in the concrete that have attempted to be coated. Common defects are that some concrete's never coated. The hole is covered with a thin skin of concrete, eventually fractures since it's not structurally sound. Like in either case, the concrete's exposed, thus defeating the purpose of the coating. It can be avoided by insisting all bug holes are exposed by opening them up and filled with the material compatible with the coating system. A bug hole, as you can see, it is more like an eye socket. So what you see at the surface of the bug hole isn't the actual size of the bug hole. Once that's prepared, the bug hole opens up, and that's what we're saying there. We fill that before we put any coating over the top of it. Pinholes, the bane of a lot of contractors that coat concrete. These holes are small, but they're difficult to see with the naked eye. They're caused by both application properties of coating and method of application. Multiple coats of material are applied to minimise probability of pinholes. From one coat aligning the pinhole to another coat, there'll be no pinholes through to the substrate unless the pinholes are lined between coats. Happen. Avoid by specifying holiday testing. There's one method to do it as a quality control procedure, and that's done after the coating application. You know, we used to use conductive primers, but we've got equipment out there now that can do that quality testing for us. Cracks. When a concrete's poured, they don't get the cracks out of the concrete that's actually poured. Reflective cracks occur generally after coating's applied. The most common reason for the concrete to crack is shrinkage, which takes place over time. Around about 44% of shrinkage occurs within the first 28 days of the concrete being poured. Most new construction projects are on tight schedules, many times insisting that concrete cure times less than 28 days, which is the most commonly specified cure time. I know the manufacturers get hit up and we get asked how soon can we coat it. This can be avoided by scheduling the application until such time as the concrete cure is adequate and agreeable with the manufacturer. Dynamic cracks. A crack that moves is dynamic. A crack can be existing shrinkage crack or a structural crack. The difference is that a shrinkage crack usually moves in two directions in the same plane. Structural cracks move in multiple directions in multiple planes. Can be avoided by identifying and correcting any defects before application, treating dynamic cracks by bridging, injection bonding, routing out and sealing with a compatible sealant. This construction joints or cold joints, EJs as we know them. Common to have construction joints crack similar to shrinkage cracks. The interface between the two cords of concrete is inherently the weakest point to give under shrinkage stress. Therefore, when the coating is applied over the construction joint, there's a high probability that the crack will flick through it. You avoid that by treating your construction joint as a dynamic crack. Outgassing. Outgassing forms blisters almost instantly on applied coatings that have had sufficient heat to resist the formation of blowholes. Heavy build coatings commonly will have blisters if the application occurs during outgassing. Depending on the conditions of use, the blisters may not affect the functionality of the coating. However, blisters usually are not acceptable. You can avoid this by specifying, inspecting, and enforcing work procedures which allow coating application only during the time when the slab is cooling, falling. The material requirements that I mentioned before, it's not just our surface preparation. The material specified, there's a few things we have to take into account there. And surface preparation requirements will vary depending on what the repair or protection materials that have been specified are. Manufacturers of the system will have specific requirements for surface prep, including profile and moisture sensitivity, and they need to be consulted. Proper surface preparation can impact the manufacturer's warranty. So therefore, the application requirements of surface must be determined by the selection of a surface preparation method. Substrate strength, we've got the tensile bond strength. Generally, that's tested prior to and or after following surface preparation, where we actually put do an adhesion test on the substrate strength. Most coatings and repair materials require a minimum substrate strength of 1 MPa. Then we've got the profiles that we require. We'll get onto the CSPs further on in the presentation, but there's different profiles there for different materials and toppings. And the other one is the application thickness. Moisture tolerance product, wet substrate, is it okay? Or do we need a dry substrate? We've got our site requirements, job site requirements, noise, vibration, dust, water generated during preparation methods. Are we in an operating environment? It's a potential for property damage. That all limits your choices. Mechanical ventilation, what power is available, the size of openings for access, minimum clearances may also affect surface preparation. Surface preparation may also release hazardous contaminants, for example, asbestos or tar, like we said before, and non-containment of any abrasive blast material with silica. Any condition that may affect the method of surface preparation needs to be considered. We've also got accessibility, like I mentioned before. We've got physical strength, like load-bearing capacity, access, turning radius of the plant and equipment we have in there, the area that's available to us. Surface, if we're looking to prepare, horizontal, vertical, overhead, slab on grade, suspended slab. Time available, how long it's going to take, the working hours that we'll be working, shutdown time, available space, obstacles, penetrations, non-movable equipment, dissimilar substrates, joints, traffic, vehicle access, pedestrian access, and the exposure, was it interior or exterior? We've also got the likes of utility supply, what electricity is available, where is it, what's it going to cost us, do we need three-phase, compressed air, pressures, locations, cost again, ventilation, can it be natural, mechanical, what capacity we need, supply equipment, do we need fans, supply of water, which is generally a big one, like getting potable water at a water treatment plant is pretty difficult, like trying to get power at a power station. Looking at the supply capability, location, drainage, where it all goes, and are pumps required. Further site requirements is recycling and disposal. The airborne is like your abrasive blasting, your liquid hydro demolition, your solids like steel shot for shot blasting, your debris, concrete, any hazardous waste. That's got to be disposed and recycled. Either one. Containment, we've got to keep airborne debris and all of that in place, got to contain that. Got to look at also noise, vibration, fumes, exhaust, all that sort of gear. And the temperature conditions, we don't get freezing, but ambient temperature, surface temperature, the differential between the two, and in instances of extreme heat. Evaluation of surface preparation methods. Selecting a method will provide that clean substrate that we're looking at. It's got to optimise the success of the material installation. It requires knowledge of available options. Profile achieved following surface preparation is the primary requirement. Preparation methods. Selecting and specifying the method. Final selections based on the relationship between the substrate, condition, material requirement, job site conditions. We just looked at. Specification can include a CSP range as well as other criteria. One strength requirement we mentioned with the substrate. The requirements should be clearly defined in the spec, along with test methods that need to be used to evaluate the preparation. The concrete surface profiles, CSPs. Several of the methods summarised and capable of producing a range of profiles on concrete. ACRA has identified 10 profiles. The profiles have been replicated on a rubber swatch to replicate the anchor profiles, the degrees of anchor profiles considered to be suitable to the application of different type of materials. And that one gives us an idea there. There's our different CSP levels. If you've got it on a big screen, it looks a lot better. Each carries a number ranging from CSP1, which is nearly flat on the top left-hand corner there. That's a dash, while we don't do that too often these days, through to CSP10, which is very rough, and a profile of over 6 mil. These profiles, the replicas were through a variety of preparation methods, as we can see there. And what we've done is represented the profile height that's required for the different products. Molded replicas provide clear visual standard for purposes of specification, execution, and verification. You can also go by feel. They're benchmark profiles and can be referenced in specifications, material data sheets, application guidelines to communicate the required surface profile. Probably more than one profile will produce acceptable results, and a range of suitable profiles is generally specified. There is a caution note that texture and appearance of the profile may vary depending on the concrete strength, the size and type of the aggregate, and the finish of the concrete surface. Sound substrate, the range of variation, significantly controlled to resemble the reference standard. Depth of removal increases, the profile of prepared substrate will be increasingly dominated by the type and size of the coarse aggregate within the concrete. A type of protective system or a repair material to be applied will impact the type of surface preparation selected. For example, penetrating sealers have little or no effect on the appearance of the prepared surface. Any surface defects, contaminants or profile resulting from the surface preparation will be visible. High build materials will have both high hiding power and ability to fill irregularities of the surface. Smooth finish over higher profiles may be achieved by increasing the thickness of the coating system. Manufacturers often have minimum thickness requirements, which can be affected by surface profile. A surface profile greater than that specified by the manufacturer may result in increased costs through more products. Overlays and repair materials are generally installed such that the depth of the material or the amplitude of the surface profile. You see there's a chart there that shows us the material to be applied and the surface profile that's recommended. Sealers go from CSP 1 to 2, thin build 1 to 3, high build 3 to 5, self-leveling like a flooring product goes 4 to 6, and the polymer overlay goes 5 to 9 with concrete repair 5 to 10. Same chart, preparation method and what it'll achieve. Low pressure water will give us a CSP 1, grinding 1 to 2, abrasive blasting 2 to 7, shock blasting 2 to 9, high and ultra high pressure water, CSP 3 to 10, and scabling CSP 7 to CSP 9. The mechanics of concrete removal. What we're going to do here is just have a quick look over the different types of surface preparation that can be used. We look at the methods here, and we look to ensure that we're not going to damage the surface. We don't damage the reinforcement. Vibration or impact won't weaken the concrete, and we're going to look at the mechanics of various methods. This should determine the potential of each preparation method to achieve the desired result, and also assesses the potential for damage that may be caused. First one we look at is abrasive blasting, used to clean and profile concrete surface. The process can provide a light, clean profile, often referred to as a brush blast or a whip blast, or it can be used to achieve a moderate profile. It's also used to remove surface contaminants in thin, brittle coatings or adhesive films from surfaces. Corrosion products will reinforce steel. Abrasive blasting should be performed sufficiently as to remove weak latents and solid contaminants. This procedure will open up the surface of voids, bug holes, and air pockets. Substrate to abrasive blasting to provide a clean, sound substrate, uniform anchor profile, but not erode the surface beyond what is necessary. Recommended blasting methods: we can do dry abrasive with air blast. We can do hydroblasting with an abrasive with an airless. Hydroblasting with abrasive and water, and airless centrifugal wheel blast. Vacuum blasting is another alternative. Method can be used horizontal, vertical, overhead, suitable for interior, exterior applications. Both vacuum recovery and wet abrasive blasting equipment are sometimes used to reduce environmental contamination. Abrasive blasting is often used to mitigate micro cracking caused in the concrete surface through other methods. The advantage of abrasive blasting is controllable profile, profiles the steel surface, effective in tight spaces. It's cost effective, even in small jobs. The removal uses a compressed air stream or water as an abrasive media, with an abrasive media to clean the concrete and steel surfaces. Removal is accomplished by the eroding effect of the blast media, impacting the surface at high velocity. Surface profile 2 to 7. And once again, that will change depending on the duration that the exposure of the blast stream on the concrete. Accessibility, small size and portability of hose and blast nozzle provide virtually unrestricted access to all surfaces, including edges, corners, recessed areas. Limitations are not recommended for the removal of resilient coatings or adhesives, tar-based materials. When in occupied space, you need to protect equipment from dust infiltration, and it's not suitable for removal of significant quantities of concrete. Small blast pattern on it. So, yeah. The environmental factors relates a little bit to what Martin presented last week. The dry abrasive blasting produces airborne dust containing silica particles, and also the material being removed. You have to look at containment and disposal, depends what's being removed. You can inject water into the blast stream to reduce dust, or you can use a vacuum recovery system. Noise levels are generally exceeding 85 decibels. Grinding, method used on horizontal, vertical, overhead again to smooth slight surface irregularities and removes thin coatings, rigid high-build coatings such as epoxy polyurethanes. Grinding can also be used to remove mineral deposits, effervescent rust, other deposits. Used on almost any substrate, interior and exterior. Removal is accomplished by the rotation of abrading stones or discs applied under pressure at right angles to the concrete surface. Grinding stone or disc is moved across the surface to achieve the desired effect. Profile is CSP 1 or 2, so it's smooth. Generally, other methods can be used with grinding to get the profile. Yeah, the small handheld grinders produce gouging, generally in a circular groove pattern. Walk behind units eliminate the gouging. They show a circular pattern, but the walk behind ones are frequently used for polished concrete and parts for application. Limitations, not recommended for preparation of coating or sealing, unless followed by shock blasting or high pressure water blasting. It's not a liquid for removing thick coatings or acrylics and carbon adhesives, and no good for trying to remove any material that may smoke or burn when heated. Accessibility, generally everything's accessible. Equipment ranges from large to handheld grinders to walk behinds. Access to corners by configurations restricted by the arc of the grinding disc. Environmental factors, produces dust containing silica contaminants. Put a vacuum system on it, which is generally the norm. And once again, the debris, you have to look at how that's disposed of or contained and disposed. Wet grinding can be used to minimise the airborne dust, produce a slurry residue, which once again, probably that requires disposal, and you need to hit that with a bit of water pressure to get rid of that slurry. That can be a debonding factor for a coating or repair system. Grinding soft materials will probably generate smoke, and the noise level with that system is low. High pressure, ultra high pressure water. Now this is generally 5,000 to 45,000 psi. So in other words, it goes from being able to prepare a surface to being able to demolish it. High and ultra high water pressure jettings are used to remove latents, scale all of that contamination. Suitable pressure nozzle, we can get rid of epoxy, urethane, thin overlay systems can be removed. Can also be used to remove carbonated, weakened, delaminated concrete, undesirable concrete from the substrate, suitable for horizontal, vertical, and in overhead applications. Method will clean the reinforcing steel. However, flash rust may occur. High pressure water may be also used for hydro demolition, and that's referred to in the ICRA guideline 310.3. The advantage of ultra high, you can use it, rain or shine. Yes, they're going to get wet anyway, probably. Effective on horizontal surfaces, vertical, effective with no coatings, thick coatings, rubbery coatings, cleans cracks, reveals areas of weak concrete, removes joint material if desired or leaves it intact. and if job requires it, can be effective in tight spaces. No dust, easy to dispose of spent water, and easy cleanup. Removal is accomplished when the water jet strikes the surface. The degree of removal is controlled by the force of the water, pressure and volume, and the length of time the water gets in contact with the surface. Multi-jet systems rotating at high speed, 1,000 to 3,000 RPM, spread the force of the water over a large area, resulting in minimal contact time with the surface. Multi-jet systems are effective in removing contaminants in weakened concrete. Single water jet rotating slower speeds, 300 to 900 RPM, or oscillating, concentrates the force of water and produces a longer contact time with the surface, which results in more aggressive removal. Single jet systems are effective in removing sound and unsound concrete. Profile that we get off high pressure and ultra high pressure, CSP 3 to 10, depends once again on the concrete, how long we keep that there. It's horses for courses. Generally, a trial area is done to determine the pressures. The UHP water jet contractors know their rating and know what's required, and they basically do a trial panel, and we have looked at that. So that's what we need. Accessibility. There's a wide variety of portable and removable equipment. Most services are easily accessible. Tight spaces, you can get in there with a handheld lads. Limitations. Once again, if we've got equipment around that can be impacted by water, need protection, and we've got to look at the possibility of flooding. Protect electrical wiring and conduits. Protect equipment and the equipment actually requires regular maintenance, and it's reasonably expensive to set up. You need a good ventilation in tight spaces so you're able to see what's going on. Environmental factors, produces loud noise, mist, significant volume of water introduced to the work area. The water that's introduced to the work area can range up to 150 litres a minute, and it's covered by the pipe and removal performed, and the requirements of the equipment selected. Environmental regulations may require containment and regulated disposal. Frequently, the pH of spent hydrogen water is spent as well as the look at low pressure water cleaning. The low pressure water cleaning, it's used to use dust, fibrable material debris, water-soluble contaminants, used in interior spaces, for horizontal, also used as a final rinse on other surface preparation methods. Water sprayed at pressures less than 5,000, doesn't remove any significant amount of concrete. Profile gives us CSP1 and accessibility. Your low pressure water is basically handheld lance, readily accessible to most sites. Limitations, again, is protection, not can't use it for removing sealers, coatings, etc. Environmental, that's mixed in a large volume of water, debris, disposal, and exploration. Handheld concrete breakers, they're classified by weight. 14 kilo class jackhammers, the chipping hammers down to 9 kilos and under, generally. Service application of chipping hammers to remove deteriorated chloride contaminated concrete from around reinforcings to handheld concrete breakers, also used as a preparation for overlays, as we can see in the slide photo there. Removal is accomplished by the impact of the point chisel with the surface, pneumatic, electric, or hydraulic. The impact of the tool on the surface fractures and splits the concrete, and the surface using chipper hammers or handheld concrete breakers will require further preparation, either sandblasting, water blasting generally, to remove micro cracking and Profile is CSP7 to CSP10, it's pretty severe in accessibility. Generally, the chipping hammers can be used anywhere, but the general use on horizontal surfaces. Limitations, they induce microcracking. They can damage reinforcing and other embedded items. The chipping hammers, they're used to minimise bruising and significant loss in productivity when braking action is up and downward. Environmental factors, concrete breakers will produce airborne dust. So we've got the containment of dust. We've got to dispose of the dust and the debris. Noise levels exceed 85 decibels. Vibration levels are moderate to severe. Vibration can transmit through the structure, and the vibration of the reinforcing steel may dislodge the reinforcing steel from the surrounding concrete. So yes, we need to be wary of that. Scabbling, it's used for horizontal surfaces to remove concrete, brittle coatings, urethanes, may be used to deeply profile concrete surfaces. Handheld units like bush hammers are available for vertical and overhead surfaces. We've got two types of scabbling I've touched on here. First one's mechanical. That removal is accomplished by the impact of a scabbling head on the surface. Piston ripping cutting heads, pneumatically activated, repeated blows. The profile it gives is CSP 79. Then we look at hydro removal. Hydro scabbling, no vibrations or oscillations. Profile is the same, CSP 7, CSP 9. Accessibility, most surfaces accessible. Corners recesses can be done. Limitations, I recommend is removal of elastomeric membranes or gummy materials such as carpet adhesives. Mechanical, environmental factors, well, that's where we've got our airborne dust again, containment. We've got noise levels to exceed 85 decibels. Vibration is moderate to severe. Work areas require ventilation. Whether with the hydro, safer environments, no harmful silica dust or contaminants released, no requirement for disposal of dust, noise levels are lower, no vibration, special ventilation is not required to prevent dust in occupied areas. Shot blasting, generally used for floors. Preparation for horizontal services. Handheld machines are available for vertical services. Use at interior, exterior. The advantage is a uniform profile, good profile, high production rates on large areas. Removal is by the pulverising effect of steel shot impacting the surface at high velocity. Steel shots propelled against the surface. It's removed, collected with the aid of dust collection system. The removed material is separated and it's reused. Profile can be anywhere from CSP2 to CSP9. Accessibility, shot blasting equipment is available in a range of sizes to access most surfaces. Removal widths range from 130 mm to 1.2 metres. Edges and corners can be detailed within 6 millimetres of vertical surfaces. Limitations, generally not suitable for removing resilient materials. Overlapping passes lead to a striping pattern, which means there's deeper removal on the overlap area. Cannot effectively get to edges. Can't manoeuvre in tight spaces. Environmental factors, they produce very little dust. Most models will be fitted with a filter and lower the level of airborne dust. Generally now makes it more on vacuum. Ventilations may be required when operating petrol diesel propane powered units indoors. Needle scaling, not done all that often. It's basically a method to be used even underwater. It's frequently used on edges, tight spaces. They can't be accessed by larger equipment. Removal. Removals accomplished by the superficial fracturing. and of the concrete surface pulverisation. Profile is CSP2 to CSP4. Accessibility, available in several sizes, and generally unrestricted access. Limitations, not recommended for thick coatings, removal of sound concrete, and it may produce microcracking. Environmental factors, it produces dust, so we've got our normal requirements for containment, disposal, and low noise levels. Now we get industry standards. I'm just going to go through this because there's quite a few here. I'm just going to brush over. New industry standards identify the methods of surface preparation used on concrete surfaces. Unfortunately, most of the standards focus on the preparation of floors or concrete substrates that are bare rather than previously coated. Standards do not provide definitive acceptance criteria for judging the degree of cleaning. Accordingly, while the methods described may be suitable for use on concrete, the language in the standards doesn't specifically provide acceptance criteria when removing existing coating from the surface. The first one that we look at would be the SSP, SP13 and ACE5, surface preparation. That's basically dry abrasive blast cleaning, wet abrasive blast cleaning. Water cleaning is SSPC, SP12, and ACE number 5, or ASTM D4259. These methods remove poorly adhered coating, intact coating remains. It's just once again another overseas that we have written up in specifications. Impact tower tool preparation is to ASTM D4259. The big one that's used more often than not is the ACRA Guidelines 310.2 for selecting and specifying concrete surface preparation overlays. This is referenced in a lot of specifications, and it's used by a lot of specifying. ASTM D4258, standard practice concrete coating. Methods of broom cleaning, vacuum cleaning, air blast cleaning, water cleaning. 4259 again, braiding concrete. It includes grinding power tools, capable. As you can see, there's a myriad here that touch on it, but no one goes into it in depth in these. Look at the, just on that, there's also the WASA, Water Service Association of Australia, the WASA 201, 2017. That actually has a full section on surface preparation of concrete. Failure avoidance, here we go. Okay, failure avoidance. Update your coating specifications. The coating specification or repair specification is the control document for failure avoidance. Specification is a living document, adapts to new information and new proven technology. Experience a failure, make sure you understand the mechanism of the failure, the best way to avoid reoccurrence. Update the specification to reflect new methodology. Use the issues described that we've looked at today as a checklist to determine which issues are important. The key is to go beyond what coating to apply and how to apply it, get down to the details that make or break the project. Enforce the specification. All too often, well-written specification is not followed. Somehow, the presence of getting the job done right takes precedence over doing it right the first time. The same, we never have time to do it right the first time, but we always have time to do it twice or even more. Insist on sufficient scheduled times to perform the job properly. Don't agree to shortcuts for the sake of expediency. Inspections and enforcement tool for a successful project. Having a technical rep from the manufacturer present at the startup is useful, but it doesn't take the time of, doesn't take the place of independent third-party QA inspection. Record keeping is critical. Post-installation problem solving. If you do experience a failure, accurate records help determine what went wrong. And that's me done, Nicole.
Thanks, Mike. A couple of questions have come up. One was just, I guess, about the specifics for a recommendation on the method to achieve a CSP 8 on the wall of a concrete tank. Would that be hydro or a combination of?
With the, if you look at CSP 8, you'd be looking at probably, yeah, definitely be hydro. You're not going to get that with abrasive blast. Well, you would if you were there for a week, but generally CSP 8 would be hydro, in my opinion.
Yep. Okay. And in terms of failures, do you think there's enough sharing of mistakes in the industry so that we can all learn from it?
I look at it that all of these failures, Graham, are preventable. And as I said at the start there, 95% of failures that we experience are from inadequate surface preparation or product application issues. I think timing is a big factor of it. I think when programs are done for projects, you know, it's fine to say, well, on this day, this is where we're going to be, but we've got to allow for the full procedure of surface preparation through the product viewer in a lot of instances. And in a lot of instances, that's cut short. You know, we've got to get it on and get it out of here because, yeah, tomorrow this is going to happen. And I think that quite often applications are led by programs and timing, which inevitably can come back and bite you.
Yeah, that's right. It's haste makes waste. It's not just the concrete cladding industry that suffers. Yes. Well, are there any more questions coming through? I don't think there are at the moment.
Nick Critchley from MCM has asked, is there a less subjective way of measuring CSP categories visual inspection, or other than visual inspection?
Yeah, use your fingers. You can feel it as well as see it.
Yep.
Photograph it and blow the photo up. That's just what else we can do as well. I know it's visual, but in taking the photo and blowing the photo up, we've done it many times. We've even magnified it to get a CSP rating. But yeah, but as I said, feel can do it for you as well. I know rubber doesn't feel like concrete, but the profile is what you're looking for there. So tips can do that.
Mm-hmm. Good. There's let me just check this one. Quite a few thanks coming through, Mike, from various attendees, so that's good.
Very good. That's what we're here for.
Yeah, and we're sharing and
creating an awareness, right? If it helps prevent failures, it's worthwhile.
Absolutely. Yeah, we waste too much money and disputes and lawyers' times on arguing the toss after the fact.
Yeah.
The few questions, the presentation will be available on ACRA TV, as Nick likes to call our YouTube channel. And should also make an honourable mention, it is Nick's birthday today.
Yep.
Happy birthday, Nick.
Do I mention? Oh, okay, big 5-0. Well done, Nick, thank you. Yeah, and just in that context, yeah, Nick does a hell of a lot behind the scenes. I'm sure those of you who have come to our various live seminars in the old world know that she's usually there supporting and herding the cats back into the room after the breaks. It's not quite the same effort these days, Nick, but we do appreciate you getting these Zoom things working. It's wonderful. Thank you again.
Absolutely.
And happy birthday.
Thank you so much, guys.
Yeah, well, somebody's suggesting there might be a timing for a specification presentation, but let's just see how we go there. Thanks, Jamie Stone, for that suggestion. We will be keeping the webinars going. That's a nice segue into, again, thanking Mike for putting the presentation together. Pardon me. If there are any post-presentation questions, get them through to Nick and we'll field them as appropriate and get back to everybody. Pardon me. Our next ACRA presentation is on the 8th of July, which is a post-COVID-19 survey. Maybe we're a bit premature on that, but let's just see how we go. What we've done, we issued a survey to our members back in April, was it, Nick, or May? I think it was May. On how COVID had affected the various players in the remedial industry. And we were quite pleased and impressed with everybody who did put their time in to give that feedback. Victoria's copying a rise in a few of their postcodes down there. Sorry for those people who are going through that at the moment, and we suspect we haven't seen the last of it. Next week's panel will be moderated by Caroline McConaughey from MaxBuild. Caroline's also one of our active ACRA board members, so she'll be moderating that. The panellists are from all sectors. Again, we've got the spread from consultants, contractors and suppliers from Australia and New Zealand. So we're covering our geography and our constituents quite well. It would be nice if we happened to pull an asset operator or owner out of the hat, but let's see how we go. Thank you again for your time, people, for sitting at the desk or the laptop in a sparsely populated cafe somewhere. Please do the next one, and we're happy to take on suggestions for future webinars as well. Last minute questions, none floating up. There's quite a few votes of thanks and a couple happy birthdays, Nick. So we might wrap it up. It'll end fairly abruptly when Nick presses stop on the recording, I think. Thanks again, Mike.
Thanks, guys.
Thanks, Mike. Bye.